Hi, welcome to this YouTube video about this. This is the binwatch. It's a binary wristwatch. Why is it a binary wristwatch? Well, it's a binary wristwatch because the time is encoded in binary instead of in decimal. I'm going to teach you how to read it. Okay, so we read it like any binary. You will read any binary thing, and you add 4 plus 1. In this example, 4 plus 1, that equals 5. Then 4 and 4. This column or row column is the hours, and these ones are the minutes. So you have 5:45. It just changed, but I can confirm it is 5:45. More. The battery it uses, it's one of these batteries, CR2450 battery. Let me show you. This is the battery, as you can see. CR2450 3-volt lithium battery. It says lithium, but it isn't rechargeable lithium like in phones and all of that. This is more of an old style battery, watch battery, but not watch because it's more like a small remote battery. If you're asking yourselves, why did it choose this very thick battery instead of one of those sexy CR232 batteries? It's because this one has 650 milliamp hours of battery life. And let me open this up. It's just press fit. I warn you, this is not pretty. Lots of hot glue. Ew. Why is there so much hot glue around the battery? Well, it's because these battery holders I bought, they are not very good, and the battery just starts moving and falls off, and every time the battery falls off, obviously the watch loses time, and so I just prefer to hot glue it. You're never going to see this unless you change the battery, of course, but and the case is a 3D printed case. I just designed this and put some holes over here for one of these standard things. Here I have some prototypes. This is one of the first prototype of the case. It wasn't supposed to be like that. It wasn't press fit. It was just literally hot glued into here, and to change the battery you'd have to pull it out. I didn't like that, so that's why I changed into this. I'm going to show you now some prototypes of the PCBs. Well, no, they are not prototypes, more of soldering prototypes. This one, it's actually, this is the first one I made. It actually looked a little bit better, except for this. If you can see, the MCU is a lot better here than here. Some soldering problems, but in this one you have the quartz crystal. You can see it. This one no, You can't. It's over here in the back. These contact points are, you will solder some cables into this, and then you will connect them into an Arduino Uno or whatever, Arduino Uno, and just program it, use it as an ISP and program it. This is a PCB without any soldering, brand new. Now a bit more technical, let's get a bit more technical. These are just normal red LEDs. Why red? Because it's the most efficient LED color. It needs the less power to turn on. Something about the chemistry, I don't know. A button, this is a resistor for the LEDs, and this, the MCU, it's an at mega 48 PAU. I chose this one simply because it was the only one that was on stock, and the P because the P stands for pico power. That means that this microcontroller uses minimal power and it can be powered on with one of these batteries. This battery kind only supplies 3 volts. A normal Arduino will need something around 4 and 5.5 volts. This one is from 1.8 to 5 point something. So yeah, it will work until it reaches 1.8 volts. There's also brownout detection program into this chip. Then this is the chip that keeps time. It's a PCF85. I don't remember the name, I just read it. 8563 from NXP Semiconductors. I also chose this one because it was the only one in stock. The chip shortage is getting rough. But also because this one works at 3.3 volts, and the same reason because of this one, from 1.8 or something to 4 volts, more or less. The normal RTC, I think it's called real-time clock, you can get on Amazon for Arduino. It uses 5 volt logic, so that wouldn't work here because we don't work with 5 volts. Also the processor, the MCU, microcontroller, whatever, it's clocked at 1 megahertz to save power, and the clock, it's from the inside crystal. It has oscillator. So this one, use this one, it's clearer. This one, it's just for the RTC. It's a standard 32.768 or something kilohertz quartz crystal. What more? Well, in the programming side, I'm not very proud of it, but it just is. Now it's sleeping, the MCU. This one is not. The microcontroller is sleeping, but when we press the button, it wakes up. If you're curious, it's, well, read it and to see if you can read it. Turn down the. It uses, supposedly I couldn't measure it, but it uses minimal power while it's in sleep mode. And I think I believe that because it's been like a month since I've been running this thing, and the battery is working great. The LEDs are dimming a bit, uh, but for the rest of it, it works. And yeah, see you later.